Hi, everyone. Welcome to RedMonk Conversations. I'm Rachel Stevens. I am a senior analyst at RedMonk, a developer-focused industry analyst firm. And with me today, I have Dan Moore from FusionAuth. Dan, would you like to introduce yourself?
Yes, thanks so much for having me today, Rachel. I'm Dan Moore. I'm head of DevRel at FusionAuth, and I've been a developer for over 20 years. And now I get to spend my days helping developers build secure authentication and authorization experiences with FusionAuth.
Excellent. That sounds wonderful. The thing that I'm excited about, even though we're both doing this call from our respective homes, is that we're both in the Denver metro area. So it's always nice to have friends in the Denver area. We're looking forward to chatting here. So one of the things that I'm excited about for this call is that I feel like we're going to do a little bit of the head fake move of, I think a lot of times when we're talking about authentication and authorization providers, like you kind of think about it from that user authentication angle, where we're talking about kind of getting people successfully logged in securely to their applications and thinking about that angle. But what we're talking about today is actually really interesting and more complex than that, I think, in some ways, because we're going to be talking about how to authenticate your APIs. And I think that the reason why you need to authenticate APIs is going to, I think, become very apparent as we talk. I'm going to turn the floor over to Dan. He has some slides that he's going to help walk through with us so that we can illustrate some of these points with visuals I'm excited about, but I think we're still going to try to keep it really conversational. And we're going to talk about why we need to authenticate APIs and how FusionAuth can help. So Dan, take it away.
Great. So we're going to talk about API authentication today.
Awesome.
And
well, this is my slide.
Yeah, right. I think this is your piece of bringing a lot of your expertise, looking across the landscape.
Yeah. So I'm excited. I promised you all visuals to help walk it through, and then we just have my slide, which is me talking to you.
Boom.
All right. So one of the things that I think we have noticed, and I'm sure everyone building applications out there has probably noticed this as well, is that the way that we're building applications these days is really modular and composable. So if you think back to ye olden days of application building, and it was somebody who was building things from the ground up, and you're putting together these huge apps of things that you have written yourself. And now we have services coming together from internal and external partners. We have microservice applications. We have things that are driven by kind of managed service providers, all of these things coming together in libraries and ways that we're trying to get our applications to talk to one another. And to do all of that successfully, everything is really driven by APIs for the most part. That's how all of these services talk to one another. And APIs are a really crucial part of how we are assembling applications. And so that is the landscape that exists around this problem space, is that we're trying to build applications in this modular way. In order to do that, we have to have our API story locked down. Does that cover what you wanted?
Yeah, actually, I had a question for you about that.
Yeah, go for it.
So do you feel like it's the kind of proliferation of APIs and the fact that they're fundamental building blocks for apps nowadays is driven by cost, speed of delivery, resilience, or some combination of all of those? Like, what's the main purpose why you see developers wanting to like build APIs out, or is it new capabilities or something else I didn't ask?
I think it's maybe one of those yes and things, but of the ones that you mentioned, I would say that velocity is probably a driving factor for most companies in terms of trying to have things that they can get to market faster. And that's why we have gone in this world where we're piecing things together in a way where things don't have to release at the same cadence. We can have things written in different languages. We can have things sourced from different places, and all of them come together to serve the whole, but they're not all necessarily tightly bound. And so I think the velocity one is probably one of the ones that's the main driver and a main concern for most engineering teams.
Awesome. Great. Cool. Thank you. So let's kind of jump into, now that we've set the stage for why you need to build with APIs, or you should strongly consider it, like, let's talk about why you want to protect it. And there are a couple of reasons that jump to mind. First of all, you may want to build for your APIs. Again, that kind of depends on your business model. You definitely want to be able to control access to it in terms of just raw, like how many requests per second are coming against my API. And then at a more granular level of who is accessing what, right? So certain users with certain roles or certain privileges should have access to some APIs or some functionality, and others should not. Another thing that's really important is to think of the security risks. So these are all things that can happen if your API is not protected. And you may say, well, gosh, everybody who's building an API will certainly protect their APIs. But there was actually a paper, or not a paper, an article I found written in 2021 that talked about 3 name brand companies that had API mistakes. And it was directly related to them not controlling access to their APIs. Parler was one. That was that conservative social media site that had an unauthenticated endpoint that allowed someone to, or many people actually, to download a bunch of data. Clubhouse was another one, and there they had public profile data that was made available on all, I believe it was all of their members. And that's okay, but what they didn't have in place was any kind of throttling mechanism or anything that let them know who was accessing this data. So people were able to scrape all of their members' data, which again is probably not what they intended with their API strategy. And the third was LinkedIn, and LinkedIn lost something like 700 million users' data, or the 700 million of their users' data was available for sale, and some hackers, I hesitate to use the word hackers, some attackers downloaded that data through their API, and that included things like email addresses and physical addresses. So it can happen to you, and you just want to be aware of this and take steps to make sure that you don't join that unsavory company, unfortunately.
I feel like the loss of PII and kind of those security risks are things that keep, like, both people who are working directly with the technology all the way up to the C-suite, like, keeps them awake at night, kind of fears of wanting to make sure that they are not exposing their company, their users, anyone to these kind of liabilities and risks. But I do think it's one of those things where the prevalence of it is such that sometimes it starts to feel like it's inevitable that somebody is going to have an issue, and we're going to have to do things. And I'm sure we're going to talk about this more. Is like, how do we make the right thing the easy thing? So one of the things that we kind of have explored at RedMonk is having the thought about the developer experience of writing and making this application code secure application code, and like that, making the developer experience actually part of your security consideration so that developers can do the right thing. And so I'm excited to hear more about what you have to say about this.
Yeah, and absolutely. And I think that is a really salient point. And we'll dig into this a little bit later, but I think one of the things that you can absolutely do that really will help developers make the right choices is to follow standards, right? Don't roll your own, because I've been on some of the, authentication mailing lists. And I can tell you that people on those mailing lists that are helping build those standards, which is a slow process, I'll grant you, but they think about all kinds of edge cases, and they have, you have all these great minds coming together. And so it's a different level of DX, right? As opposed to tooling, but like going with a standard rather than coming up with your own solution is just a super easy way to stand on the shoulder of giants.
Yeah, I think that's wise. I think it's important. We're not talking about user login necessarily on this call, but like it's a lot more to consider than a name and a password field when we're starting to put all these things together. So
100%. All right. So let's talk about some authentication options for your APIs. And I'm going to go over each of these in depth, so I'm not going to read this. I hate when people just read slides, but I wanted a summation slide. The network layer is where you're controlling access based on MAC address or IP, or whether someone is logged in with a VPN. And it's an okay solution if you are within your corporate firewall and you have kind of that level of control. But as soon as you step outside of the corporate intranet, then you can't use this essentially as a way to authenticate APIs. It can be an input into your API authentication, like intelligence layer, but it is not going to be the total control, because if you have a SaaS solution or if you have a consumer facing solution, you're just not going to be able to control what network people are connecting to your application from. API keys are a great place to start. Basically, it's a string that, or a random string that you hand to various people, and they present that, and that is basically their credentials to get access to this API. It is a secret you need to protect, which means that if you start to put APIs into browser-based applications or native applications, you need to start worrying about bad people extracting that string and going off and making requests against your API with that API key from a botnet in a different country. And what the ramifications of that are, you have to make sure that you think about rotating it. And one thing that's really important about API keys is they're really great if you are protecting the API and you're making it available to developers. But what if that developer has users that they want to make services available to, right? Like that second tier of API access is really more difficult to get granular with API keys. Certificates are another option, and this is built on the PKI X509 infrastructure. And it's really great if you own clients and servers, right? If you own kind of that whole chain. Deployments have been problematic in the past when I've talked to people about this. They do expire and they do take place kind of underneath the layer of the application. So you get authentication, but you still need to kind of build an authorization piece on top of this too. So this is an approach that's taken by service meshes like Istio, right? Where they kind of control everything within the Kubernetes cluster. It's very easy for them to, relatively easy for them to issue client certificates and make sure that that mutual certificate authentication is happening.
Might be one of the only times I've heard Istio described as easy. Does it happen very
relatively
often?
relatively easy. No, I mean, I will say, like, I have not delved deep into Istio, but I think that from what I've seen, the way that they've done that kind of client certificate stuff is, if not easy, at least far easier than rolling it yourself, right? Like, the idea of like having a CA and issuing certs and making sure it gets deployed to all the correct services and they all have all the correct credentials is something where I would lean on something like Istio or Linkerd.
Fair enough.
Not saying it's easy though. So tokens are a really good option, and they can pair with any of these other solutions, right? And you can definitely mix and match these. Tokens and API keys are probably the most similar, so probably going to pick one or the other for those. But they're time bound, so they're time bound credentials. As I mentioned earlier, they're standards based, and not just a standard that came out last week. They have been iterated on for years and years. The first version of token-based API authentication was really OAuth 1, which was released in 2010. And within tokens, depending on the implementation choice, you actually can have rich data structures inside a token. So that, unlike an API key where you're presenting it and it's kind of a binary yes or no decision, or you need to go look up the API key in a different service, a token can have role information, user information, other authorization information inside it itself. And because you can sign tokens, they actually have a built-in integrity. Another thing that's really exciting to me about tokens is we're moving towards the ability to tie tokens to particular clients. And I have some diagrams coming up talking about, what's a client, what are some other pieces of the token ecosystem. But with tools like Depop and MTLS, you can actually bind a token to a particular client, as opposed to an API key or a regular token, which are basically bearer tokens, they're bearer credentials, might be a good way to put it. But the idea with a bearer token or an API key is anyone who holds the thing has access to the resource that's protected by the thing. Whereas,
so like the bearer bonds of the technology world. This is exciting to me. Okay.
Exactly. Yeah. It's exactly that. Or I always use the analogy of a car key, right? Like if I give my car key to my neighbor, or someone steals my car key, my car doesn't care, and it will turn on just as well for them. But there are some tools that are coming out that will actually let you tie the key or the credential, in this case, the token, to me. Well, I mix my analogies here. Imagine a key where it's like bound to my fingerprint and it won't turn on. The car won't turn on unless my finger is on the key. That is what's coming down the pike with some of these new standards. So I think that's going to kind of be it's an additional level of complexity. And I can talk about some of that complexity, but it is an additional level of security as well.
One thing I wanted to ask, because you mentioned that tokens are signed. Are they not encrypted? I thought tokens could be encrypted.
So you can both,
Okay.
you can
It's
sign
an
them
either
or
or
encrypt
thing.
them.
Okay.
Actually, if you encrypt them, by definition, I think you're signing them, but it's a lot more prevalent in my experience to just sign them, which
Mhm.
basically means don't put a secret in there, but like you can verify if someone's tampered with the contents.
Okay. Gotcha.
Yeah. The last, I think, benefit of tokens is that they really separate concerns out. You have a server that takes care of the authentication piece and then issues that token, and then everybody else downstream of that server basically consumes that token. So you can add on layers of security or layers of checking or layers of, dare I say, machine learning on top of that authentication event. And everybody downstream benefits from that. Everyone that's consuming that token benefits from that without having to implement a single other piece of additional functionality. They just, if that token comes through, it's a valid token. So they don't really care how it gets issued or what steps the user has to, the user or API has to go through to get that token.
Gotcha. So like a stateless verification after it's already generated.
Yeah, but but I was more thinking that in terms of like over time, the authentication event can get more and more complex. And
Okay.
the tokens, the APIs downstream don't have to care about it. They just say, "Oh, there's a token. I get to do what I want with it." But an example we often see is people start out with just, you know, again, depending on your API structure, people start out with users just logging in and getting a token and then presenting that token to APIs. But suddenly, an API becomes more risky, and so users are now required to do MFA against that authentication event before they get that token. This is a rough token architecture. This is a simplified architecture diagram. Obviously, yours is going to be more complex than this, but we have clients, which are there are other servers or web browsers or native mobile apps. We have an authentication server. In the OAuth world, that's called an authorization server. In the SAML world, it's called an identity provider. In the everyone has their own words for it, but it's basically where the user gets authenticated, and or where an API entity gets authenticated. And then we have the resource server, which is the thing that contains the data that we want to protect from either other APIs or from users. And you probably are going to scale this out, right? You're not going to just have one API, you're going to have two or many. And all of those, again, can benefit from the single point of authentication at the OAuth server. So I always like to talk about responsibilities for these different pieces of the architecture. So the first is the client. The client is the thing that holds the token, and it needs to make sure that it protects the token, right? It takes care of it, especially if it's a bearer token. It needs to make sure that it provides the token to any request it makes of the resource server. And then in the OAuth world, you have this concept of token expiration because they're pretty stateless. And so they're only good for a certain period of time. And so the client basically needs to make sure that it can handle when a token expires, right? It catches it notices when a token expires. Typically that happens when it tries to make a request of a resource server and that request fails. And then it can reach back out to the OAuth server and with a refresh token. And we can kind of dig into how that works mechanically in a little bit if we want. But this is what the client needs to do: protect the token and then present it, and then make sure it handles the situation where the token expires.
Is there any standard for how often a token tends to expire? Or is it just a it depends story?
Yeah, it's 100%. It depends. The real question is, what is the threat model if someone steals your token? And if you're building a recipe sharing website, then the threat model is pretty low. If you're doing a banking piece of software, then the risks are pretty high. Again, depending on what that token allows access to. Things that we think about are, we tend to recommend that it's seconds to minutes for a token to expire. especially because you can refresh things fairly easily. Other things to think about are if you have a longer lived token, you can actually implement something called step-up auth, which basically happens during certain kind of higher risk activities, right? So you might have a token that's good for a while, and it lets people access their bank account, like view the account. And then as soon as they want to transfer money to someplace else, you actually make them re-authenticate. So that's a way to kind of layer on another layer of security so that you have longer lived tokens.
Very cool. Thank you.
Yeah. So we also have what's called the authorization server, and this is where the user authenticates, or the API authenticates, I should say, either one. And it's really about protecting user and API data. It's about authenticating the user, or I should really change this to say entity as well, and issuing the token, and doing that in a standards-based way. And our real recommendations for the particular grants that are laid out in the standards are these. Let me take a step back. Sorry. Grants are just workflows where it's been standardized, like how the flow moves between the client and the OAuth server, the authorization server, and the to-do API or the resource server. Those are all called grants, and there's maybe 10 or 12 of them that have been codified in the OAuth world. But the two that you really need to know are the authorization code grant if you have a user that's involved that is going to be making API requests based on their authentication and authorization status, or if you're just talking about API to API communication, then the client credentials grant is what you want to know about. So those are all the other grants are kind of icing on the cake and definitely help with edge cases and different situations. But if you only take away two grants from this talk, definitely the authorization code grant and the client credentials grant are what you want to do, what you want to make sure that you can support.
All right, everyone, make a note.
And the last thing the authorization server needs to be able to do is support token validation. And that can be either kind of a disjoint token validation that happens without contacting the authorization server, just based on kind of how it builds the token, or a token validation where you present the token to the authorization server and it says, oh yeah, this is one that I created. We're good. The last element of this architecture is the resource server, and the responsibilities the resource server has are to validate the token, right? Either of the ways that I mentioned earlier. And then it's really, really important here. We see lots of people who say, okay, I validated the token against the authorization server, I'm good to go. But you really need to write some business logic to validate the claims that come in the token. And that could include things like the roles or scopes or other pieces of data that are in that token. And unfortunately, that's not something a library is going to be able to help you with. You're basically going to need to write some business logic to say, okay, has this token expired? Is this token created by an authorization server I trust? Am I the intended audience of this token? Does this person have the roles that they need to have in order to get access to the requests that they're making, or this person or API? So I just want to really lean on that. It's not enough to say this token's valid, I presented it to the authorization server. You need to really dig into what you expect that token to look like.
And does that all live in the payload? Where does that live?
Yeah, so that I don't actually have a slide in this deck that I can bring up, but basically, yes, it is all in the if it depends on how you validate the token. There are two main ways to validate the token, but in either case, you'll get back a bunch of JSON, and then it'll be keys on that JSON. So the three kind of standard ones that you always want to check are issuer, which is who created this token, audience, which is this token for me, and expiration time. But the nice thing about tokens is that you can put other things in there, and those things, those other pieces of information are going to be business specific. And so that's what you're also going to want to check, right? Those three standard ones, yes, definitely. But then other things that are really specific to the domain that you're working in.
Oh, I see where you're wanting to go with this next slide. Before we go there, the question that has come to me as you've kind of presented all of this is, why not do all of this with an API gateway?
Yeah, it's a great question. So I think API gateways work really well with OAuth servers. They kind of go hand in hand. But I think API gateways, by their kind of nature and their design, are really set up for that one-tier system, right? Where you have a developer that is maybe registering with a developer portal and getting a client key and maybe a client secret or something like that. And then they're presenting that to the API gateway, and the API gateway can check against a database and say, okay, this entity is acceptable. Where you might want to get a little bit deeper is and reach out for a system that's an OAuth server that handles many different users and many different types of APIs, is where you want to have kind of two layers, right? You won't just want the developer to have access to the API. You want users that are using the application that developer is building for them to be able to get access to an API. And so you just have a much better level of granularity if you go to something that is building tokens. And as far as I know, there are definitely API gateways out there that can consume tokens. I don't know any API gateways that really generate tokens. So that would be my answer is API gateways are great, and they definitely can help with the throttling and the security and the billing pieces. I think that adding on a system like FusionAuth behind the API gateway to help issue those tokens is going to give you a richer, more granular set of controls.
Gotcha. So you kind of think of them working in conjunction with one another.
100%. Yep.
Gotcha.
Yep. Yeah, that's a great question. Thank you.
Sorry, didn't mean to derail. Tell us about FusionAuth.
No, it's great. So FusionAuth is a system that can help. And again, as Rachel mentioned, the question that Rachel asked, it's a really good point to mention that FusionAuth is part of your system for protecting your APIs, and a critical part because it takes care of the management of the entities that are trying to access your APIs and what permissions they might have and issuing the tokens. FusionAuth supports OAuth, OIDC, and SAML. We support those two main grants that you really want to make sure that you use, right? The authorization code grant and the client credentials grant. We also support some others. FusionAuth is embeddable. So we have people running in Kubernetes clusters. We have people running on kiosks. It's a low profile, very performant system, and it does run pretty much anywhere. So we have people running it on all the major clouds and in their data centers. And as I mentioned, even on some hardware, like in fact, we have one passionate user who's been running on his Raspberry Pi for years. And the other, it's pretty awesome actually. And the other kind of thing that's really important to note, and one reason that we want to support this is because of our developer roots. We have a free community edition. So we believe the best way for developers to get going with Auth is just to download something and get going, as opposed to having to talk to a sales rep or having to do any kind of application process. Like you can go to fusionauth.io and click the download link and be up and running in a few minutes. And this is not a crippled edition. There are features that are available only in our paid edition, but we have plenty of people running large businesses with, thousands and thousands of different applications or tenants that they're actually using FusionAuth for with our free edition.
Very cool. And sorry, just to clarify, when you're saying paid edition, do you have a managed service in addition to the licensed download version?
Yeah, it's a good question. So we actually have this pretty interesting deployment model where you can basically run FusionAuth in two different ways. You can run it yourself, and then you can pay us to run it for you. And then within those two choices, you can choose to take advantage of paid features, which include things like SCIM, or we have a threat detection system that takes a look at like what authentication is happening and sends various events and takes various steps to help make it more secure. But you can get those paid features either self-hosted or using our system. So it's kind of a two-dimensional access.
Okay.
Yeah.
Gotcha.
Yeah. Um,
All right, so here's our quiz at the end.
Here's our
Everybody, are you ready?
close. Yeah. So the first step is please protect your API. Please don't be a LinkedIn or a Clubhouse and not and shoot yourself in the foot. Make sure that you think about API authentication and authorization from the very beginning. Definitely, you can layer it on towards the, at an outer layer using an API gateway in combination with a solution like FusionAuth, but it's better to kind of have it be built in the beginning because you're going to be able to make it more integrated throughout your system. OWASP has a great list. OWASP is just a great security resource in general, but they have a top 10 APIs issue list, which I don't have a link there, but if you Google that, it will pop up. And authenticating and authorizing APIs, I think, is number 2 or number 3 on that list. Unless you have a good reason, I would definitely look towards OAuth for your API authentication because, again, you're just standing on the shoulders of all those OAuth and identity nerds who really spend a lot of time thinking about and bringing different experiences into play to build out those standards. I don't know about you, but I think that the number of people out there that are working on authentication authorization that are bringing their experiences to bear are going to be, how do I put this politely? They are probably going to build a better authentication authorization system than you will be able to roll yourself. And you should definitely take advantage of the knowledge that they're putting out there in the form of standards and other tools such as FusionAuth. Last thing is there's a lot more information about authentication, OAuth, OIDC, MFA, all of this in a non-vendor specific context is available at our resources page. So we feel like we want to educate people about FusionAuth for sure, but we also, as hopefully was indicated by this webinar, want to educate people about authentication and authorization in general because we feel like it's such a critical topic that unfortunately a lot of people just want to get through as quickly as possible. And we feel like that's a major source of weakness and issues with applications today.
Gotcha. Well, thank you so much, Dan, for taking the time to talk. This has been a lot of fun to chat with you about how to authenticate our APIs and to build stronger and better applications with a better user and developer experience. So thank you so much.
Thank you.